Good morning, my lovely twelvers. Right, buddies, today is the lesson that I have been waiting for. Today is the day that you get to see my very favorite application of matrices. They are so sick, they will blow your mind. They're amazing at solving simultaneous equations. So if you put the title, Solving Simultaneous Equations with Matrices, I shall show you how it works. Now, pretty much, if you look at a simultaneous equation like these two, so you just got two little basic equations, just two variables, two unknowns, like this, you don't really need a matrix to solve them because they're all quite easy. But what you're going to find out pretty soon as you go off to university and do something like physics, certainly, but chemistry and stuff as well, and maths even for that matter, sometimes you'll end up with tons of equations with tons of unknowns. So in physics, for sure, you know, you've got your horizontal and your vertical directions, like when you do mechanics, you can have a horizontal direction, a vertical direction, and two different things depending on each other in each of those two directions. So you can have 4 equations and 4 unknowns, which is a palaver to solve. So wouldn't it just be a result if you could just literally type it into your calculator and it would say what the answer is? Well, you can, because that's what these matrices are going to teach you to do. I'm very excited. Okay, let's do it, my buddies. Okay, first ever question says this. Use the matrix method to solve the simultaneous equation. Now, this is going to blow your mind, and then you're going to be like, I can't believe I didn't even spot that all along. Okay, here's what you're going to do. See how we have these two equations, 3x plus 2y is 17, and 2x take 5y is 24. You should write them down to start with. Now, here you go, my buddies. I'm about to blow your mind. This is what it looks like in matrix form. Well, the 3 and the 2 just put out 3, 2, and this is just going to be 2 and minus 5. I've literally just copied these coefficients into the matrix, haven't I? So 3, 2, 2, minus 5. I copied them into the matrix. But I know what you're thinking. You're like, yeah, but that's not a simultaneous equation because these guys, that's not even an equation at all because they don't have x and y in. Guess what, buddies? Hold your breath. Here we go. Oh my word. What does that times out to make, my buddies? Well, let's look at it. 3 times x is 3x, 2 times y is 2y. That's the top one. Oh my word. And the bottom one, 2 times x makes 2x, minus 5 times y, minus 5y. Look how easy it is to turn a simultaneous equation into a couple of matrices. That's so sick. But what's it supposed to equal to? Well, 17 over 24, of course. Isn't that cool? So look, it's just this written in matrix form, and like, you know that this makes the top one, the 3 and the 2 end up being the top one, which equals 17, and oh my god, it's like almost looks like for like with, yeah, it's almost like for like with the thing above, which is ace. Cool. Which means this, my buddies, can you see, I'm going to try to not make it sloppy, so I'm just going to try to explain, but, yeah, do I want to make it sloppy? I'm going to make it a little bit sloppy, and then I'm going to erase it, okay? Let's just pretend that this guy, see this guy, this matrix here? If I wanted to get what x and y are, which is the solution to the simultaneous equation, because you're trying to figure out that's what a simultaneous equation is doing, then here's what I need to do. I need this bad boy gone off this side, so what'll I times it by? I'll times it by its inverse, yeah? I'm going to times it by the inverse of that on the left, which means all I got to do is times this by that same inverse thing on the left. And then it works out with matrix multiplication, with all that stuff that we've been practicing so much, it works out. Now that's a sloppy Joe thing, so I'm going to get rid of that. I don't like that, so just erase all that out. But that's what we're actually about to do. Okay, you ready? We just need the inverse of this then. So let's do it. Get the inverse of that. So here we go. If our original matrix is 3, 2, 2, minus 5, and we want to get its inverse, I hope you remember, what's step 1 again? That's it, the determinant. So get the determinant of it, and then it's going to be 3 times, that's going to be minus 15, minus 4 more, which is minus 19, isn't it? Happy days in the determinant? Cool. Which means that the inverse matrix is actually going to be this. It's going to be negative 1 over 19, and then what it's going to be is, flip the main diagonal, minus 5, 3, and negative the other two, minus 2, minus 2. Like a boss. So there's your inverse matrix. So what are we going to do? Well, just like what we said before, we're going to times it, and I'm going to erase this again because I don't want it to look sloppy, but I'm going to times it, both of these on the left with the inverse matrix, because this is going to kill the blue thing, leaving you just with the xy. So what will we end up with? Well, we'll end up with this. We'll end up with, on this side, xy matrix equaling the inverse, which is minus a 19th, minus 5, minus 2, minus 2, 3, times 17 and 24. Cool beans? So I times the inverse in on the left, which means xy is equal to, and I'm not even going to try, I'm going to calculator this, negative 1 over 19, it's going to be a 2 by 1, so let's just get that little gap ready. Okay, what's going to be minus 5 times 17, minus 5 times 17, minus 2 times 24, so negative 133, so what I've got here, minus 133, and then on this one here, I'm going to go minus 2 times 17 was minus 34. Oh yeah, I have to put it all in though, so may as well type it. Minus 34 plus 3 times 24 is 38. So you're going to end up with that. Now remember, the minus 1 over 19 is just a scalar. You can times it into every single element to get rid of it. So 133 divided by 19 makes 7. So we're going to be left with positive 7. And on the bottom, 2, isn't it? Cool. And that's it, my buddies. Cool beans. So what's the solution? Well, the solution is this. As a point, the solution is 7 comma 2, or as how they do it in GCSE, x equals 7, where y equals 2. Like a boss. Happy days. There's your solutions, buddies. And no problem. Now, it was still quite mechanical. You might even argue that it was a little bit more steps than just doing it out normally, but don't forget there's a bit of a shortcut here, which I'm going to enlighten you with right now, okay? So, yeah, cool beans. I hope you get it. Is that okay? I hope it's okay. Now, here's what we're going to do. Example 2, I'm going to go through 3 types of things that can happen. This one here had a determinant that was non-zero, okay? So this was a non-singular matrix, whereas if we have this one here where the determinant is also not zero, it's also non-singular. Yeah, anyway, here's what we're going to do. This time, my buddies, we're going to cheat big time in the calculator. So here's what I'm going to get you to do. Make sure you got your white calculator to hand. If you've not got your white calculator to hand yet, go get the big graphing calculator, okay? You need it. Pause, go. Okay, and you're back. So here's what I'm going to get you to do. What you're going to do is you're going to write this out in matrix form for me, ready to go, okay? So pause, go. And you're back again. So let's do it. In matrix form then, this one's going to look like this. 2 minus 5, 3, 2. It's going to get times by x, y, because of the nature of how matrices times out, that that their rows and the columns match up. That's why this works so well. And then this is going to be 24 and 17 on this side. No problemo. Okay. Now, here's what we're going to do. I'm going to allow you to cheat, but I don't think you should cheat unless you're told to cheat, because sometimes they let you cheat on your questions I'm about to set, but sometimes they don't. I want to use the calculator, okay? So we're going to use the calculator to just get the answer in one go. Okay, so I'm going to go straight to a final answer, and it's going to be amazing. But I don't want you doing this on your homework, because I have to see that you can actually do it, okay? But I am still going to teach you the calculator, because you need to know that this is sick, my lovelies. You've got to know that this is awesome. Okay, we're going to go straight to a final answer. So you ready? XY. When you do this in physics and stuff, or when you do this at university, you'll just go for the final answer as well. So, yeah, this is awesome. Here's what I'm going to need you to do. So I'm going to try to explain it. I'm afraid that I don't... Oh, I guess I could put the camera on, but it'd be awkward to show it to you, so I'm not going to. I'm just going to explain it. So make sure your calculator is in just like normal mode, okay? So it should only just be a blank screen, and then it should say Mat in the bottom left corner with an arrow. If it doesn't, just push X it a whole million times until it's clear. Okay? Here's what you're going to do then, buddies. Number 1, push that Mat button, which is F1. Once you've got that, it should probably have a bunch of matrices in it that you were playing with last time, but that's no problem. So let's just go into matrix A, because it's the top one. It might already have something in it, but don't worry. I'm going to overwrite mine. So the third button in, F3, says dim. That stands for dimensions. So choose the dim, and the matrix that we're going to do is a 2 by 2. So switch them both to 2, and then push equals. It might already be filled in with other numbers, and it might not be. It might be 0, 0, 0, 0, or it might be previous numbers, so it doesn't make any difference. Type it in exactly how you see it. 2 minus 5, 3, 2. Cool beans? Got it? Nice one. Okay, all you're going to do now is push exit. Now you're back on the matrix screen. Go to matrix B. Choose it. I'm going to choose dimensions because mine's already got something in it. You can either delete it and start fresh, or you can choose dimensions. The dimensions is a 2 by 1 this time because we want to go a vertical column vector or column matrix. So yeah, happy days. And in that one, put the other two numbers, 24 and 17, and then push equals and equals. Exit out, and now you've got two matrices in there, matrix A and matrix B. And probably the others are empty, but it doesn't matter if they are or they aren't. Cool beans? Right, exit until it's all the way back at the start screen again. Cool? Here's what you're going to push. Options, which is beside shift. Push options. Now it says list, mat, complex, calc, stat. Well, we're playing with matrices, so 2, mat, F2. Cool? What do we want first of all? Well, we want mat, so choose mat, and it should just say mat now. Now, the matrix that we're going to be on about is matrix A, but we actually need its inverse. So number 1, it says mat. Now push alpha and push A, which is just underneath it. So it just says mat A, right? Now, that's going to output the 2 minus 5, 3, 2 thing. So here's what we're going to do. To get its inverse, it is, and I know this sounds like it's taking forever, but it won't in the future. To get its inverse, all you're going to do is push the to the power of button, which is the triangle that's 2 to the right of alpha. Push the to the power of button, then push negative, which is at the bottom beside exe, and then 1. So you have mat A triangle minus 1. Matrix A to the power of minus 1. Your calculator understands that what you're trying to do is make an inverse. Cool? Then all you're going to do is now you're just going to push mat again. Oops. No, hang on. Oh, I made a mistake. Then you're going to push options again. So now I pushed X, so I'm exited all the way back to the front again. Now choose options, and now choose mat again, then choose mat in F1, and then choose B, because that's where you put the point. Push equals, oh, then you get math error, because I forgot to push times in there. Times, and you get the answer! So, oh my gosh, maybe I should explain it again because I made a mistake. So your screen should say this. Your screen should say mat A to the power of minus 1, then times, then mat B. Then you push equals, and by God, if it doesn't output 7 and minus 2, what a result. Which means as a point, the answer then is either 7 minus 2 or x equals 7 when y equals minus 2 as a final answer, all in the calculator. Took me a while to explain that, but it'll be instantaneous for you when you guys do it. Just to show you as well, what you just found there, what you just found there was this exact thing, okay? So this proves it. There it is graphically. There's the two equations. We wrote them out in matrix form just like they did there. And we found in this case, we got a unique solution. Now, I'm going to tell you, the unique solution is because the determinant was not equal to 0, okay? The determinant of the matrix was not equal to 0. That's why we got a unique solution. Determinant of m is not equal to 0. Because if the inverse exists, buddies, then that means that we can undo the transformation, or we can undo the simultaneous equation, and we can get what the answer is supposed to be. So that's interesting. The determinant doesn't equal 0, which I bet makes you guess the next question. What if the determinant is equal to 0? Cool. Right, well, let's try it and find out. You could put this in your calculator. It'll say math error if you do. But you can try it if you like. Yeah, maybe you should try it. It'll say math error if you put it in. But here we go. Number 1, look at this. It says use the matrices, and you don't know this yet, so we're still going to show this. Use the matrices to solve this. X plus 2y is 10, and x plus 2y is 4. So let's do it, buddies. In matrix form, write it down. Go. Well, that's it. It's 1, 2, 1, 2 times xy, and that's going to equal 10, 4. Cool? Well, what do we need now then? Because if we're going to try to get this thing on its own, and I don't want to cheat in the calculator for this whole thing, I need you not to cheat in the calculator for all of them. I wanted to show you, but you can only cheat on some of them, okay, buddies? Anyway, this is what we've got. Well, let's try to actually solve it. We need to get it. We need to get the inverse. So if m is equal to 1, 2, 1, 2, well, that means that the determinant of m is going to be 1 times 2, which is 2, and 1 times 2, which is 2. Take away 2. So the determinant of m is actually equal to 0, which means no inverse, because it breaks maths. Yeah, because it's 1 over the determinant is the inverse formula. This hasn't got an inverse, which means that this hasn't got a solution. Okie doke, it hasn't got a unique solution. So here's what you need to spot, my buddies. If you check it out, why do these guys not have a solution? Okay, so this is no solution. Why though? If you look at it, like, even bin off the matrix if you like, but if you look at it, my buddies, what do you notice about these two things? Well, yeah, these lines are actually going to be parallel because the constant number doesn't play a role in the gradient. Oh gosh, I'm going to show you. What the heck? I'm going to write it in y equals mx plus c to really prove my point. Okay, so this one would be y equals negative a half x plus 10, and this one would be y equals negative a half x plus 2. That one was 5, wasn't it? Plus 2. Yeah, plus 5. So there you go. So look, buddies, they're parallel lines. So they don't have a solution because they're parallel. When you're solving a simultaneous equation, you're saying, where do they equal each other? Well, literally nowhere. They're parallel lines, but they don't equal the same value. They have no solution. They're parallel. Okay? The thing to spot is two things. The first thing to spot, maybe I forget what's in here. It might actually already be listed in here. Let me just see. Oh yeah. So there you go. Yeah, cool. Well, there's something else I have to note. So there you go. There's the parallel lines. There they are actually shown. There they are actually shown on a graph for you. So you can see that they're parallel. That's why you don't get a solution. So the matrix thing didn't work, but it didn't work because the simultaneous equations don't work either. They're parallel. They don't have a solution. The thing to spot there is two things, okay? Here, oh, I'm doing an impromptu note. Here we go. So to spot, okay, to see if they're parallel. For parallel. Okay, to spot for parallel. Well, here's the two things that you spotted. The two lines of the rows in the matrix are multiples of each other. Now, you know, because you guys are really clever, that because these two rows are multiples of each other, that actually means the lines they represent have the same gradient. Cool? The rows are just multiples of each other, too, but the other thing that you're going to spot is that they don't equal the same thing on the right. The same point, the column vector, no, the same, yeah, point on the right. I'm going to say point on the right. Cool. And that's it. One final thing. So there you go. That's how you can spot that they're parallel. Determinant 0 already means you can't solve it, so it's parallel or it might be something else. And the other thing to note is that they are multiples of each other, but they are, yeah, determinant 0, these are multiples of each other if you don't want to do the determinant, and they don't equal the same point at that side. Whereas this one's a little bit different as well. This is also a determinant equals 0 case, but check it out. Let's do it. If you check this bad boy out, matrix form, write it in matrix form for me, buddies. Well, yeah, if you got this, 1, 2, 3, 6 times xy equals 1030. That's what you got. So let's see if the determinant is 0. Let's actually confirm it. So let's go m equals 1, 2, 3, 6. That means that the determinant of m is going to be 6. Take away 6, which is 0. So already no inverse. Okay, which means it's not got a solution. It's not got a unique solution. Now, here's the one difference here. If you check this one out, can you see that this is 1, 2, and 10? Well, if you check out the bottom one, 3, 6, and 30, can you spot anything common among the 3 and the 6 and the 30? Well, yeah, they all divide by 3, which means this, if you divided all of the components that of the lines, or just in the equation itself, 3, 6, and 30, it would become x, 2y, and 10. It's the same line twice, buddies. Can you see that? What you've got here in this scenario, which is what you just got to check for, is if you get a determinant that equals to 0, but you just find that the two lines are multiples of each other, well, they're when you divide them by something they equal the same line, well, that means that they are actually the same line, and there's an infinite number of solutions, okay? So the answer to this one here, my buddies, is an infinite number of solutions. Number of solutions. They're the same line. Cool. What is it to spot it? So oh, and this is called, okay, and this is a cool word as well. If the lines are the same line as each other, they're called coincident, or yeah, they're coincident with each other. They're on top of each other. That's what that actually means. Okay, so to spot coincident. Cool. Here's what it is. 1, same as last time. Well, determinant is 0 for sure. We already have that up here though, so the determinant of m is equal to 0. They're multiples of each other. Lines are multiples, matrices are yeah. Matrix, rows are multiples. But the only difference thing is though, the right hand side, ooh, how do you even say it? The right-hand side is also by the same multiple. How do you say that in words, though? So 3, 6, 30, if you divide them all by 3, it becomes exactly the same. 3, 6, 30 becomes 1, 2, 10. The right-hand side is affected by the same scale factor, maybe. Did by the same scale factor as the matrix. That's a really awkward way of saying it, as the matrix. Now, the thing is, this becomes so quick and so easy. You don't really think about the words, and it's so hard to write it down, but it's quite easy to see what I mean. Get it? So 3, 6, 30 simplifies down to 1, 2, 10, so they're clearly the exact same line. That wasn't the case here. 1, 2, 10 was already simplified, and 1, 2, 4 was already simplified, and they're not the same line. 1, 2, 10, 1, 2, 4. Not the same. Not the same line. Determinant equal to 0. The lines are parallel. 1, 2, 10 and the 3, 6, 30 becomes also 1, 2, 10. They are the same line. These lines are coincident because they're the same line. They're on top of each other. Happy days, buddies. This one here, determinant not equal to 0. A unique solution because we can actually use the inverse. And boom, the 3 cases. And boom, you're done learning matrices. Hooray, my buddies. I'm going to give you a practice lesson next lesson. But that's it. You've done matrices. You've finished year 12 further maths matrices. How exciting! Okay, cool. Boom, try them. Page 140, question 1 to 8. Do a bit of a mix. Please don't do them all in your calculator, although do some in your calculator. Give yourself a mix. Treat yourself. Do a calculator on occasionally, and then do it without a calculator occasionally as well. So I definitely know that you can apply the matrix inverse formula. And I think it's got some 3 by 3 ones in there too. Well, I don't think you learn how to do a 3 by 3 inverse until year 13. So definitely use your calculator for that, for sure, for sure. Cool beans, buddies. And that's it from me. I shall see you next time for our revision lesson. Bye, buddies!